Hey everyone, this is a video for Lab 2. We're actually in one of the smaller meeting rooms because the lab was a little bit noisy, if you remember last time from the fume hoods. And in this lab, lab number 2, we are going to do a very simple liquid-liquid extraction. And actually, let me show you what's on Moodle right now. Okay, I hope I'm still recording and you can see my Moodle screen. So liquid-liquid extraction, if you've done the reading, PDIAS, and then also the lab handout, it's a way to separate a mixture based on solubility. Because as we become more familiar with the polarity of solvents, not solvents, but polarity of molecules, we can actually predict whether that molecule is going to go in the aqueous or the organic layer. Hopefully those terms are familiar since you've done the reading. And we can make molecules more or less soluble in either of those two layers by possibly protonating the molecule or deprotonating the molecule, making it charged. That's for lab 3 actually. In this lab 2, we're just going to focus on the technique and practice taking good observational notes in your lab notebook. Let me show you the handout. Okay, in the handout that you've read, we are separating, no, actually we're not separating. We are transferring iodine that's in water into the organic layer, which is, in this case, cyclohexane. Cyclohexane is less dense, so cyclohexane will be the top layer, and the aqueous or the water layer will be at the bottom. As we proceed in the semester, the idea is for you to set up your lab notebook using what's called a pre-lab entry. The pre-lab entry is based on the, mostly based on your readings and definitely on the handout. Before watching this video, hopefully you have done the pre-lab entry, because the way we're going to proceed is I'm going to do the experiment in place of you. So as I do the experiment, we'll get to the setup in just a bit, but as I do the experiment, you will pretend that you're my lab partner and take observational notes in your lab notebook after the pre-lab entry. And again, the pre-lab entry for this case, and this is a modification, the pre-lab entry will be your page number, the date, the title, and here I'm asking you for a sketch of a separatory funnel with 2 layers drawn in that separatory funnel. And you'll see a real separatory funnel in just a second. It says here, after the procedure, answer these 2 questions. Actually, I'm going to ask these 2 questions in the post-lab. So what I am expecting from you after you've done the reading, fill out your notebook, watch the video, take observational notes, what I'm expecting from you is 2 submissions. One for the, here they are. One for the notebook and one for the post-lab problems. Okay. Let me get to the setup and show you or demonstrate how to do an extraction. Again, you are taking observational notes, but you can definitely pause the video, you could rewind it, but when I grade your lab notebook submission, I am looking for the pre-lab entry and your observational notes. How detailed are you? So, if I'll give you an example. Something looks like water, okay? You could describe that as a clear liquid, okay? But that's not good enough. You need to say its clarity, fine, clear liquid, but also you need to say its color, because a clear liquid can still be yellow or still be light blue. Clear just means that it's transparent. So If something looks like water, I would say it's a clear and colorless liquid that looks like water. If you could tell the viscosity, you could say it has the same viscosity as water. You want to be very descriptive in your when you describe these chemicals as we proceed through a procedure. Okay, and then obviously, if something changes, like if we do a reaction and that clear colorless liquid becomes more viscous, and you could tell that by the stir bar kind of having a little bit of resistance, or did it change color? Did it produce some fog or some smoke? Um, did it bubble a lot, or did it just foam up? All of those observations are going to be what's going to help you get a good grade on your lab notebook. Enough about that. I actually don't know how long I've been talking. Let me get out of this share screen. Okay, so I think I'm back. And so the water, the iodine is right here. And I'm gonna try not to spill anything on my laptop for the semester. That black stuff is undissolved iodine, okay? And I dissolve some of it into water. That white piece is a magnetic stir bar. See, this is your observation. So you're starting iodine solution, you got to describe this, okay? You got to describe this. I am looking for your observations. Cyclohexane looks like this. Cyclohexane looks like that. Right? Maybe it might be helpful if I had possibly a piece of white paper. So this is another technique. You view your solutions behind a white piece of paper. There's a modification to the procedure, and the modification is, I don't want to keep jumping back and forth between the worksheet and the video, but the modification is we are using only 20 milliliters of the iodine aqueous solution and only 20 milliliters of the cyclohexane organic solvent. Okay. Now, I know that the other part of the procedure is do the extraction again, but now instead of using one serving of 20 milliliters of cyclohexane, you're going to do 10 milliliters twice. And really the purpose of this lab is to see if there's a big difference or any difference between splitting up your cyclohexane or doing one gigantic one serving of cyclohexane. That's double the amount of the other part of the procedure. Okay. So make sure you get that change that we are only using 20 milliliters of iodine solution per extraction. So the extraction. Let me make sure that the stop clock is closed. So when the orange bar is horizontal, that means there's no hole connecting the separatory funnel vessel and we could call this a spout. Here's the neck, way up here, and this is the stopper. Okay. No grease. The glass-to-glass joint should be good enough to keep the liquid within the separatory funnel. I'm going to pour out 20 milliliters into a graduated cylinder. It doesn't have to be exact. And my stopcock is closed. So you see where the aqueous solution, aqueous water. The cyclohexane is here. I could use the same graduated cylinder because I wanted all of that iodine solution in here anyway. So it's almost like rinsing your cup, right, with more of your water. And try to get all the material into the separatory funnel. And what are we doing first? I think we're going to do the procedure where we use one serving of 20 milliliters of cyclohexane. Keep an eye on what's happening with the separatory funnel. This is, again, practicing good observational skills. So as your partner pours, can you describe what's happening in the separatory funnel? So pour all of it. Without any shaking and mixing, let me put this, let me actually carefully put this a little bit closer. Without any mixing, we have those two layers. Now, I told you that cyclohexane is less dense, so it's the one that's floating. It's the one that is fairly colorless. The observation notes based on that. Okay, something's a little bit different. Now, when the separatory funnel is resting in the clamp or the ring stand, you want to keep this. Want to keep this unstoppered, okay? Because you don't know whether the two solutions are going to produce gas. If it produces gas and there's a stopper right here, sometimes the glass-to-glass joint gets stuck, okay? And if you're producing a lot of gas, you're going to build up a lot of pressure. And the best way for that pressure to be released, if there's too much of it, is to explode the glass outward, okay? Or to, like a rocket ship, eject this stopper upward, okay? So I've seen extractions where the force of the pressure, the pressure created enough force to blow the stopper to impale this stopper in the ceiling. Okay, so you just want to be careful. Keep it always unstoppered. Because I'm pretty afraid of gas production, okay, I don't think a lot of gas will be produced, but a good habit is in your first shake, you stopper it, okay? You take it out of the ring clamp, you invert it, and then you release any pressure gas, any gas, okay, like this. So now it's open, okay? Before any shaking, when you invert it, go ahead and release any excess gas, just in case gas is being made, okay? And then go ahead and stopper it. Not stopper, but close the stopcock. Close the stopcock. So the idea is you're going to try to mix these two immiscible solvents so the iodine has a chance to be transferred from the water to the cyclohexane. At least that's what we're expecting. The process to do this is shake, vent, shake, vent, shake, vent. So I'm going to shake, and then I'm going to vent. Okay? I'm going to shake, I'm going to vent. I'm going to shake and vent. Back to the ring clamp. All right. If your partner did exactly what I did, what should you be telling your partner right about now? You should be telling your partner, I'm going to get point deductions, or we're going to get point deductions because the stopper is still in the separatory funnel. Always, see, it was stuck a little bit. Always let the separatory funnel rest unstoppered. Okay? Now, I think you can see it in the video that there's still a couple layers, but we have some bubbles here in the middle. But we definitely have a fairly colorless layer at the bottom, and now this layer at the top. Okay. Now it's the time to pause your video and then take more observation notes. All right. While this starts to separate. I don't know if you can see it, but the bubbles are starting to dissipate. I really want to see two distinct layers with a very clear border. Okay? So very clear border. Sometimes we're not going to get that. Sometimes you get what's called an emulsion, right? You know that oil and what's mayonnaise? Oil and water? I'm not sure what mayonnaise is actually, but mayonnaise is an emulsion because normally the ingredients that make mayonnaise separate, but they whip it up. They create a lot of surface contact between the two or three immiscible ingredients, and they form mayonnaise. Same thing here. We're getting an emulsion. Not that bad, but definitely we're not getting a clear demarcation between the two layers. Now you could say the layers are water and cyclohexane, or you can say the layers are aqueous and organic. Okay, the layers are not going to switch places. So if your organic layer is less dense at the beginning, it's going to be less dense at the end, no matter if anything is dissolved in it or not. Okay. So do we remember which one's the aqueous layer? Remember where this layer was, the orange layer. Okay, it's at the bottom, right? It's at the bottom. So we definitely see something different. And this is our first extraction. Now you want to drain the bottom layer because that's the one we're collecting and we're going to analyze by sight. So the idea here is you want to drain, but don't get any of the second layer, the top layer, into your beaker. So you can drain slowly. Okay, the bubbles, I don't want really the bubbles there. So my technique is to stop it short and then let it settle a little bit, maybe agitate a little bit. Okay, getting there, right? Again, if your emulsion is bad, it might take a little bit of time, but see, I'm getting more of the clear, colorless solution. Well, from my point of view, it's not quite colorless, and I'll show you in a bit what I'm seeing. I'm draining it into a beaker, and this represents extracting the aqueous layer once with one serving of 20 milliliters of cyclohexane. That's the first part of the experiment. Now, I'm not going to get every single drop of the aqueous layer because I don't want to accidentally get some of this organic layer. So I'm going to stop short, but I do have quite a bit. Okay, and I'm going to put that into a test tube. So we're going to analyze this by sight. We're not going to use the spectrometer right now, today. This one is going to be on the right. Sorry, the left. Okay. I have another test tube. I'll separate it here. That will be for our second part of the experiment, which we're about to do. We're done with the first part, okay? Because remember that first part was just doing one extraction with one serving. So I'm going to put this into the waste. Organic solvents should never go down the sink because they're not mixed with water. So it starts to coat everything in the sewer lines or the pipes because water can't carry it because it's immiscible. So normally you would wash this, but I have a second separatory funnel next door. Part two is now doing the extraction in parts. Instead of one serving of 20 milliliters of cyclohexane, we're going to use 2 servings, 10 milliliters each. But what does the 2 servings mean? The 2 servings doesn't mean that you just pile on 2 servings. 2 servings means you do it once with 10 milliliters, and then you re-extract the aqueous layer with a second serving. Okay? It's almost like when you're washing your clothes, okay, and you have that dirty laundry water. You rinse it once, and then you drain everything, okay? And then you add more pure water, and then you drain that. So same thing here. You're not adding 2 servings at the same time. You're adding 1 serving, do your washing. Okay, so sometimes I say washing because really what we're doing is we're washing, right? We're washing the aqueous layer and getting rid of these impurities, the iodine. So washing is still a valid term in this case. And we're washing the iodine or the aqueous layer twice. Okay, let me show you how that's done. Oh, I'm making a mess. Okay, here's my separatory funnel here, and new one. And here's my graduated cylinder. Again, same. We're not going to change the variable of how much iodine solution we're using. We're still going to use 20. I know the procedure says 25, but remember, we modified the procedure, and you have to make note of that in your notes, okay? I imagine that your pre-lab says 25 milliliters, and that's what you come into with the lab, expecting to use 25 milliliters. But during a pre-lab lecture, or maybe someone noticed that, well, 25 milliliters isn't going to fit into our test tube. So they switched it up and said 20 milliliters, and that's what we're using. So here's 20 milliliters of iodine, and we're going to do 10 and 10, okay? But not at the same time. So here's 10 milliliters of cyclohexane. Okay. Well, it's definitely less, right? This is only 10. Last time we used 20. And the idea here is we're going to do this in parts. So it is more labor intensive. It uses the same amount of material ultimately, but it's more labor intensive. Is that labor going to be worth it in terms of separating out the iodine, in terms of washing the aqueous layer? And so again, what's the technique? The technique is cap it, turn it over, vent it right away. Don't even shake it. Yeah, did you hear that? Man, I wish I caught that a little bit better. It went, psst. It released a little bit of gas. So now we're gonna shake, vent, shake, vent, shake, vent. Okay. I'm gonna push the stop clock so it's towards me, right? Shake, vent. Ah, man, it's not producing any gas anymore. Shake, vent, shake, vent. A lot of times I would ask the student to shake harder if I know the separation is a little more difficult, if the miscible solvents don't really like to interact with each other. There's our first extraction. And what am I going to do? The idea is I got to re-extract this layer here. Now, the thing is, the way it's set up, because the organic layer is at the top, I can't get rid of this organic layer and rewash with new organic layer just by removing this top layer, because it drains from the bottom. So this is the idea. The idea is to drain and get that aqueous layer, most of it as possible. Now, if you get a little bit of the pink solution, that's perfectly fine because we're re-extracting it. It's like we have a little bit of dirty laundry water, but that's okay. We're draining most of the dirty laundry water and then add new water. Okay, so I don't mind getting a little bit of the pink solution. Okay, so there's my aqueous layer, and there's a little bit of pink, but again, I am re-extracting it. But this is the dirty laundry water that goes into the waste. Now I know it's a little bit nasty here. That's perfectly fine. You don't totally clean, right, your washing machine after every rinse cycle or after every rinse in a rinse cycle. Right? You just go ahead and, using the same analogy, we're going to put back the laundry. That's now a little bit cleaner, but I could do another rinse to make it even more clean. So what's the other rinse? The other rinse is 10 milliliters of cyclohexane. There's 10 milliliters. What am I going to do? Good practice is I really wanted to get as much as this aqueous layer into the separatory funnel. So why don't I use some of this organic, pure organic layer to rinse the beaker. Remember what happened to our first organic layer? It went into the waste, right? Because what are we analyzing? Remember, we are comparing the aqueous layer. How well did we clean this by doing an liquid-liquid extraction? Okay? So there's my second serving. It's less intense because it's less dirty, right? The laundry was less dirty. So here's the stopper. Okay, maybe listen very carefully. Maybe there's like some gas. I heard a little bit, but not that much. shake, vent. Let me move it towards me. Shake, vent, shake, vent. That is the second extraction. Well, let me say that is the second serving of cyclohexane. We know that the second serving still did something because, look, the cyclohexane is still pink. So it was able to extract more iodine from our first shake vent procedure. So that's what I'm collecting here. I have a new beaker. Now that I know that I'm analyzing this layer, I want to be very careful and not get any of the organic layer with any of the pink solution. If you think about it, before I move on, approximately how much aqueous layer should I have? Remember, we started out with 20 milliliters of the aqueous layer. All right. Still see some of the more dense bottom layer, but again, I don't want any of the top layer to get into my beaker because this is the last drain before I analyze. And here's my test tube. And again, this is also the trick is you gotta know which layer is which layer. A better technique would be save everything until you know your experiment is done. But I had already put the first organic layer into the liquid waste. That's fine, because what am I analyzing? I'm analyzing the aqueous. So here are my two aqueous layers. Now, because we're not in person, I know it's super hard to see. This was our first extraction on the left. And this is our second extraction, the one we just finished. Okay, so the trick is maybe put a white background. But still, I really can't. I see a difference. Okay, but the video is not really capturing the difference between our first extraction here and the second extraction here. Well, what do we do? Actually, this is not the best point of view because we're only looking through about a centimeter of solution. So what's a better way to look through most of the solution? Instead of looking through this direction, which is 1 centimeter, I can look from the top. So I can put my head up here and look down and see there's a difference. Okay, and I do see a difference. It's just that it's going to be very hard for me to show you because, well, obviously, if I tilt this, I'm going to spill it. So I did this experiment about an hour ago. Let me show you a couple of pictures. Okay, let me find my shared screen. Okay. And then my pictures. Oops. Oh my goodness. I'm hoping you can see my screen. So here is the side view, and it's still same order. The one on the left is the first extraction, and the one on the right is the second extraction. Maybe I should have labeled the paper towel, but left was the first, right was the second. So let's take a look at, now from the top view, let's take a look at the one on the left. So here's the one on the left, and now's the time to take observational notes. Try your best. Be descriptive, okay? For instance, if I had a white powder, that's still not good enough. My class last semester really liked describing things in terms of food. So that white powder, does it look like sugar? Does it look like flour? Does it look like snow? Does it look like chalk? Does it look like shredded paper? Does it look like, well, crystals? You got to be descriptive. So this is what I see looking down the first test tube, the first extraction, and the second extraction gave me this. Okay, describe what you see, and now that's the end of the experiment. Based on, or depending on what I give you on the post lab, I may ask you to make some conclusions. Okay, that concludes the experiment. Again, when I clean up all the organic solvents, cyclohexane goes into a separate container called organic solvents. The iodine and aqueous, the iodine in water, I probably won't put it down the sink because iodine actually is a very good oxidizing agent. And I don't want to corrode any of the pipes. And also, I don't want to stain any of the, even if the pipes are plastic, there's going to be a little bit of damage. So I'll have another container called aqueous waste. And this will be taken care of by environmental waste management. Okay. Let's go back, before I sign off, let's go back to the Moodle. And just from a reminder, okay, I'll have directions. I didn't write out the directions or the post-lab questions yet. But again, the lab notebook, you really want to pretend that you're being prepared with a pre-lab entry before you walk into lab. And the pre-lab entry is based on the procedure in the lab handout. Anything that I did on the video, you got to put into your lab notebook. If there's definitely a modification, right? Literally, what would you do if we were in the room together and we were doing this experiment? Organic chemistry, we are going to veer off. We are going to do, change variables. We are going to experiment, I didn't know until we did this that, that test tube probably would not have held 25 milliliters of cyclohexane. That was a change on the fly. And you're going to see that many, many times during the lab. Well, my video was going a little bit crazy. So you have your lab notebook submission and then the post-lab submission. Both of those are due Thursday by 5 p.m. Okay? Because I do want this done before we do lab 3, which is another type of extraction called acid-base extraction. Okay. All right, if you have any questions, I think I did put also a link or a forum to ask any questions, and I'm alerted. I think everyone's actually subscribed, so everyone will know when the new entry is posted. Okay. Stop share. Still recording. All right, I will see you in class.